Random access memory. Random access memory. It works by storing common data that programs are in constant use of, rather than storing the data on a much lower medium like a solid-state hard drive or SSD. Random access memory is made out of copper. Copper is commonly used for building wire because of its conductivity, strength, and reliability. Over the life of a building wire system, copper can also be the most economical conductor. Copper used in building wire has a conductivity rating of 100% or better. Random access memory or RAM is a computer's short-term memory, which it uses to handle all active tasks and apps. None of your programs, files, games, or streams would work without RAM.
How does RAM store information? RAM is constructed of microscopic strands etched into the silicon of the memory chip. You can think of these electrical strands as pipes, like plumbing through which electricity flows. Some pipes represent addresses, while others carry data. Now let's say we want to store the letter A in RAM. First, the PC opens a section of memory by sending a burst of electricity across the address pipe. This electric burst closes a group of miniature switches known as transistors, but only the ones needed for the data along that address line. Next, the actual information is sent as electric bursts across the address lines. Each burst is called a bit, and there are 8 bursts traveling on 8 lines, in this case to represent the letter A. In the computer's code, the letter A looks like this. Each burst travels through a closed switch and charges a capacitor. The turned-on capacitors represent the ones. The uncharged capacitors are considered zeros. Because all capacitors lose their charge over time, bursts of electricity continuously flow to refresh them.
Heatsink fan. Heatsink fan. Most heatsinks consist of fins resembling that of a radiator. As the CPU or GPU warms up, heat will transfer to these pins where it's released using a fan. A fan is attached over the heatsink to circulate air. The fan runs in reverse, meaning it draws hot air away from the CPU or GPU. Heatsink fan is made out of copper or aluminum.
Metals with high thermal conductivity and relatively low cost are preferred materials to be used. Commonly used materials for heatsinks are aluminum and copper. Due to its higher thermal conductivity and volumetric heat capacity, copper would seem to have the superior thermal performance. A heatsink and fan or HSF is an active cooling solution used to cool down integrated circuits in computer systems. Commonly, the Central Processing Unit or CPU, as the name suggests, it is composed of a passive cooling unit or the heatsink and a fan.
When a chip heats up from use, a heatsink removes and disperses the heat to keep the chip at a proper operational temperature. The mechanism of transport is by conduction, convection, and radiation. The heat comes into the fins, and then the flow takes it away by change of enthalpy across the surface. Without the use of a heatsink, the chip could overheat, which could destroy the entire system. To further the
A hard disk drive or HDD is a non-volatile computer storage device containing magnetic disks or platters rotating at high speeds. It is a secondary storage device used to store data permanently. Random access memory or RAM being the primary memory device. Hard disk drive is composed of dysprosium. Computer hard disk drives contain small amounts of dysprosium compounds in their surface coatings. These dysprosium compounds are highly susceptible to being magnetized and enhance the magnetic properties of hard drives. Data is stored in the hard drive on the basis of this magnetism. The hard drive is the component that stores all the data on your computer, from files to software. It's the central storage bank for our digital lives. Unfortunately, hard drives don't have an unlimited amount of space.
The hard drive has been the main storage device in computers for decades now. Do you ever wonder what's on the inside? Hard drives are sealed so that no dust can get inside. Once you take yours apart, it most likely will not work anymore. The platters is where the information is stored. Both the top and the bottom of each platter is used so it can store as much information as possible. The actuator arm is how it reads and writes information. They never actually touch the platters, but you need a microscope to actually see that. It moves so fast that the human eye will have trouble keeping up with it. The platters are split up into tracks, and each track is split up into sectors. When you read or write to the hard drive, the actuator arm must find the right track, and the platters must rotate so the right sector is underneath the arm. It only takes a few milliseconds for this to happen. This may seem fast, but compared to newer technologies, this is much slower. In recent years, the hard drive is being replaced by the SSD, also known as the solid-state drive. These have no moving parts on the inside, which means they are faster, smaller, and use less power. However,
Cable wires. Electrical cables work by providing a low resistance path for the current to flow through. Electrical cables consist of a core of metal wire offering good conductivity such as copper or aluminum, along with other material layers including insulation, tapes, screens, armoring for mechanical protection, and sheeting. Electrical conductors are made up of metals such as copper, aluminum, etc. These metals are used to make wires. Most wires are made out of copper because it conducts electricity with high flexibility and very little resistance. The first stage in the manufacturing process of a conductor is the wire drawing. Electrical cables are used to connect two or more devices, enabling the transport of electrical signals or power from one device to the other. Cables are used for a wide range of purposes, and each must be tailored for that purpose. Cables are used extensively in electronic devices for power and signal circuits. Power supply. A power supply takes the AC from the wall outlet, converts it to unregulated DC, and reduces the voltage using an input power transformer, typically stepping it down to the voltage required by the load. For safety reasons, the transformer also separates the output power supply from the mains input. Power supply is made out of silicon.
Silicon conducts electricity to an extent that depends on the extent to which impurities are added. The addition of impurities to silicon or to any semiconductor material is called doping. Some impurities produce n-type silicon, in which the majority charge carriers are negatively charged electrons. A power supply is an electrical device that supplies electric power to an electrical load. The main purpose of a power supply is to convert electric current from a source to the correct voltage, current, and frequency to power the load.
Your computer that makes sure all of the others have the electrical current needed to do their thing. But how does it do this? Well, in order to generate electricity, you need to do what's called inside each power supply is a small mouse that quickly runs on an exercise wheel to generate power for your computer to use. So if that's the case, then wall allows a tiny shocker to shock the mouse in your power supply and get it moving. Similar to how a cattle prod works. It also doubles as a feeding tube, because after all, the mouse does need to eat in order to stay alive. So little bits of mouse food are fed through the power lines and then through the power cable and into your power supply. This is why the power cable for your computer has to be so thick. The mouse food isn't going to
Central Processing Unit. The CPU sends signals to control the other parts of the computer, almost like how a brain controls a body. The CPU is an electronic machine that works on a list of computer things to do, called instructions. It reads the list of instructions and runs and executes each one in order. CPU came from sand. It is made up of 25% silicon. Sand and quartz has a high percentage of silicon in the form of silicon dioxide, a component for manufacturing a semiconductor. Then the big ingot will produce from electronic grade silicon. One ingot weighs around 100 kilograms and has a silicon purity of 99.9%. The main purpose of CPU is to process and manipulate data in our computer. The CPU performs a task such as calculating, sorting, inputting, outputting data, and searching. Whatever activities we've done in our computers, such as browsing, playing games, checking emails, and a lot more, all the data that we use are being processed by CPU. In short, it is the main brain of our computers.
But every processor contains several important features. Here are the main ones. The socket. The socket is a type of physical connection between the processor and the motherboard, and it is responsible for transmitting energy to the processor. The core. The cores are responsible for the processing speed. The more cores a processor has, the more functions it can execute simultaneously without overloading your system. The clock. The clock is responsible for defining the frequency that your processor will use to execute one task. It's measured by hertz. This means the amount of cycles that can happen in a given amount of time. In this case, in seconds. For example, if a processor has a 2 gigahertz clock, it can have up to 2 billion cycles per second. So the higher your clock frequency is, the lower the execution time will be, which for you means a faster processor. The cache. Basically, the cache is the auxiliary memory of a processor, where the most accessed data that will be processed is identified and then stored. The processor accesses this memory and is able to execute the action faster because it's more readily available. This is one more important factor that has a direct impact on the processor speed. The more cache there is, the more quick storage capacity you have, which results in a faster speed. If you have